Imagine you wake up and the sun is exactly where it should be. But Mars is not. Your astronomy app says Jupiter should be rising. The telescope points to the correct coordinates. There is nothing there. Observatories report the same impossible mistake. The planets are drifting from their predicted positions. Not randomly. They are all leaning toward the same empty patch of sky. At first, no one says black hole. There is no glowing disk, no giant circle eating the stars. There is only gravity arriving from something the telescopes cannot see. Then the orbit of Neptune changes, and suddenly the question is no longer whether the object is real. The question is whether Earth will be thrown into darkness, captured, or torn apart. So imagine you are here when a rogue black hole enters our solar system. We will follow it through 6 stages, from the first invisible clue to the 4 possible endings for your planet. And here is the part most people get wrong. Being swallowed may be the least likely way it kills you. Stage 1. The invisible visitor. A rogue black hole is the compact remains of a massive star moving through the galaxy without a close companion. Gas falling toward a black hole can become hot and bright, but an isolated black hole may have almost nothing to feed on. No bright disk, no beacon, just several suns of mass compressed into a region smaller than a city. Give our visitor 10 times the sun's mass. Its event horizon would have a radius of only about 30 kilometers. But from a distance, its gravity behaves like any other object with 10 solar masses. It does not vacuum up the galaxy. If the sun were replaced by a black hole with exactly the same mass, Earth would continue along essentially the same orbit. We would freeze because the sunlight was gone, not because the black hole sucked us in. The danger is that it is not replacing anything. 10 suns of mass are crashing through a system balanced for billions of years. The Milky Way may contain around 100 million wandering black holes, but the galaxy is mostly empty space. The nearest known black hole is roughly 1,500 light-years away, and none is known to be approaching us. But finding a truly isolated one is difficult. You do not photograph the object. You watch what it does to the light behind it. When a black hole crosses in front of a distant star, gravity bends and magnifies the starlight. The star may brighten for months while its apparent position shifts. This is microlensing, detecting invisible mass through someone else's light. Now imagine that fingerprint is moving toward the solar system. We might discover it centuries before it reaches the planets, or miss its path in a crowded star field until much later. But the first part of our system to feel it would not be Earth. It would be a place no spacecraft has ever reached. Stage 2. The outer alarm. Far beyond Neptune, the solar system does not simply end. It fades into a vast spherical reservoir of icy bodies called the Oort Cloud. Its inner regions begin thousands of times farther from the Sun than Earth. Its outer boundary may reach 100,000 times the Earth-Sun distance. There may be hundreds of billions or trillions of frozen objects there. Most remain harmless because their slow orbits never bring them near us. A passing star can nudge them toward the inner solar system. A 10 solar mass black hole could create a stronger disturbance on a close path. But this would not look like a wall of comets appearing tomorrow morning. The Oort cloud is too large. An object disturbed there may need thousands or millions of years to fall toward the sun. The black hole could pass, vanish back into interstellar space, and leave behind a delayed storm for civilizations that do not exist yet. If the black hole is still far outside the planets, your life may continue normally. Humanity might have generations to observe it. But the orbit calculations would keep changing. Every measurement narrows the corridor, a distant flyby, or a passage inside the architecture of the planets. And there is no machine on Earth capable of pushing 10 suns of invisible mass out of the way. At 50 kilometers per second, it covers about 1 astronomical unit every 5 weeks. From 100 times Earth's distance, the approach could take a decade. Unstoppable, but slow enough to watch. Then, Uranus and Neptune begin to move. Stage 3. The Planetary Domino. The planets constantly pull on one another. The solar system survives because those pulls are predictable. Introduce an object 10 times heavier than the Sun, and prediction becomes triage. Simulations have tested a 10 solar mass black hole against the 8-planet solar system. Passes beyond roughly 2,000 astronomical units remained stable in those tests. Inside a few hundred astronomical units, outcomes became far more destructive. Speed, direction, and the planet's positions all matter. A fast object gives gravity less time to act. A slow one can pull for years. Neptune might enter a stretched orbit, be ejected, or be captured by the black hole. Jupiter contains most of the solar system's planetary mass. Change its orbit, and you rewrite the rhythm affecting asteroids, comets, and every smaller world. A planet can be destroyed while looking intact. Move Earth closer, and the climate heats. Move it farther away, and ice advances. Stretch its orbit into an ellipse, and every year swings between 2 different worlds. Our agriculture and ecosystems evolved for the orbit we have now. And if the encounter moves closer, Earth faces 4 main endings. Only one requires the black hole to swallow us. Stage 4. 4 fates for Earth. Fate 1. The damaged orbit. This is the least cinematic outcome and possibly the most survivable. The black hole passes close enough to disturb the planets, but far enough that Earth remains bound to the Sun. Our orbit changes shape or tilts. The length of the year changes. The amount of sunlight reaching each hemisphere changes. The Moon's orbit may also be disturbed. At first, you might experience this as strange seasons. Summers arrive too hot. Winters last too long. Migration routes fail. Crops are planted according to a calendar that no longer matches the sky. Humanity could adapt to a modest change. We already build shelters, controlled farms, reservoirs, and power grids. But a strongly elongated orbit could push Earth repeatedly outside the temperature range that keeps surface water stable. The black hole leaves. The emergency does not. Every orbit becomes another test. Fate 2. Ejection. Earth can receive a gravitational kick strong enough to escape the Sun completely. The planet would not explode. You would not feel a sudden jolt through the ground. Earth and everything on it would continue moving together. The first visible change would be the Sun becoming smaller each day. Weeks become colder. Photosynthesis weakens. Solar power collapses. Months later, the familiar solar system is behind us, and Earth is becoming a rogue planet. The atmosphere and oceans would store heat for a while, but the surface would eventually freeze. Humanity would retreat underground, toward nuclear power, geothermal heat, and sealed agriculture. The oceans would freeze from the top down, while the ice insulated deeper water. Life might not disappear completely. On Earth today, ecosystems around hydrothermal vents already survive without sunlight, powered by chemical energy from the planet's interior. Microbial life could continue beneath the frozen surface long after forests and cities were gone. Earth would survive as an object. It might even preserve a hidden biosphere, but the world built for you would be over. Fate 3. Capture. This is stranger than ejection. The black hole passes on exactly the wrong path and steals Earth from the Sun. Our planet becomes bound to the intruder and follows it into the galaxy. Earth would not necessarily cross the event horizon. It could orbit the black hole at a large distance, just as planets orbit stars. Simulations show that passing compact objects can capture planets while ejecting others. But a bare black hole provides almost no useful light. Unless the Sun was also captured in a stable arrangement, Earth would still freeze. Our new year would be in orbit around darkness. Look up, and you might see a distorted patch of stars circling an invisible point. The object controlling the entire planet would be visible only through the way it bent the background universe. You would have a new center, but no new sunrise. Fate 4. The close past. This is the outcome people imagine first, but even here, being swallowed is not the opening act. Gravity becomes dangerous when it changes significantly from one side of an object to the other. These are tidal forces. The Moon raises tides in Earth's oceans because it pulls slightly harder on the near side of Earth than the far side. Near a stellar mass black hole, that difference can become extreme. The oceans would not simply rise on one coast. Earth's crust would flex. Global earthquakes and volcanism could begin. The planet could be stretched, fractured, and ultimately torn into a stream of rock and superheated gas. Remember, our 10 solar mass black hole has an event horizon only about 60 kilometers across. Earth is more than 12,000 kilometers wide. A direct hit requires extraordinary precision. But the region where tidal forces can ruin Earth is much larger than the event horizon. That is why swallowing is not the main danger. The black hole can destroy the planet without ever touching it. And if you somehow approached the horizon intact, time and light would behave in ways no human body could experience for long. To a distant observer, your signals would become increasingly red and faint. Locally, the tidal difference between your head and feet would stretch you into a thin stream of matter, spaghettification. There would be no portal, no view of another universe guaranteed by science, just a boundary after which no message returns. But what would the disaster actually look like from your backyard? Probably nothing like the thumbnail. Stage 5. The sky during the end. An isolated black hole does not automatically wear a bright orange ring. That famous glow comes from hot matter falling around it. A truly dormant black hole may remain black against a black sky. You would detect the invasion through consequences. Stars behind the object could brighten or shift through gravitational lensing. Precise telescopes would measure planets drifting from predicted positions. Spacecraft navigation would accumulate errors. Radio signals would arrive from places where the receivers no longer expected the transmitters to be. If the black hole passed close enough to strip gas from the sun or capture dense clouds of matter, then the scene could become brighter and more violent. Falling material could heat up and produce intense radiation, but that depends on the path. The most realistic terror is quieter. Your night sky might still look beautiful, while the equations say the solar system is coming apart. There is no cosmic alarm. Gravity makes no sound in space. One evening, Jupiter is in the wrong place. Months later, it is no longer our planet. Then the black hole passes through, carrying stolen worlds, while the survivors continue on new paths. This brings us to the question that matters to you. Could anyone survive? Stage 6. The survivors. Survival depends almost entirely on distance. If Earth keeps a tolerable orbit, human civilization survives the encounter and spends centuries adapting to a changed calendar and climate. If Earth is ejected or captured into darkness, small populations might survive for a time in sealed underground habitats. Nuclear reactors and geothermal systems could provide heat, artificial light could grow food. But every settlement would become a closed machine with no easy replacement for sunlight. One failed harvest matters. One damaged reactor matters. One broken ventilation system matters. The challenge is not keeping a room warm for a week. It is rebuilding an entire biosphere using only the energy and materials you can control. If the black hole creates extreme tidal forces, there is no bunker deep enough. The planet itself is the structure being pulled apart. Yet life is more stubborn than civilization. Microbes beneath rock or near deep-sea vents could outlast us. Earth might carry life into interstellar space even after it loses every visible sign that humans existed. And now, the emotional release. This is not a prediction. No known black hole is approaching the solar system. The nearest confirmed one is about 1,500 light-years away. Even if the Milky Way contains 100 million isolated black holes, the galaxy is so enormous that a destructive encounter with our tiny planetary region is extraordinarily unlikely. We are not waiting for new coordinates from a hidden object tonight. But the thought experiment reveals something real. The solar system feels permanent because every human life has unfolded inside the same celestial clock. Yet its stability is not protected by a wall. It is an arrangement of moving objects, held together by gravity, traveling through a galaxy filled with other moving objects. A black hole would not need to touch Earth. It would not need to shine. It would not even need to come especially close by cosmic standards. It would only need to pull at the wrong angle for long enough. So imagine that first morning again. The sun rises normally. Your street looks ordinary. Your plans for tomorrow still make sense. But Jupiter is missing from the place where mathematics promised it would be. And somewhere in that empty patch of sky, something invisible has already found us. Would you rather know 10 years in advance, or live normally until the final week? Write your answer in the comments. Then subscribe. And if an invisible object can break our place in space, the video on screen asks the next question: does space itself ever end? Click it now.